One thing about using any virtualization system in your home lab, be it virtual machines or some kind of a container system, the first thing you tend to run out of is memory, and shortly thereafter, it's storage. So in this video, we're going to discuss Incus and how to provide more storage to Incus via iSCSI. So in December of 2023, I presented Incus storage pools and volumes, where I talked about how to add additional storage pools and how to use volumes. And of course, in the latest videos where we've been talking about Incus OCI containers, we've also used volumes as storage space for persistent data. So then the default storage pool that you get when you do an Incus admin init when you initially set up your Incus server can be enlarged, but it can only be enlarged if you have space. And if you followed Incus containers step by step, when I created that storage pool, I created it as a virtual storage pool, which means that it's created inside of a file. So if you have storage elsewhere on your network, you can use that storage for an Incus storage pool. And in November of 2023, I presented a really great tutorial entitled iSCSI Fast Network-Based Storage, where we set up an Ubuntu server, and we made that Ubuntu server an iSCSI target, and then we set up a second server which we made an iSCSI initiator, and we connected to the space that was being offered on the iSCSI target. So if you have a QNAP, Synology, NAS, or some other server on your network that's got additional storage, it can be configured to offer an iSCSI target. And so that extends to things like Unraid as well. That does have an iSCSI plugin to make it an iSCSI target as well. So why do we want to use iSCSI? Well, iSCSI offers very fast block-oriented storage over your home lab network. And even on a 1 gigabit per second LAN connection, iSCSI outperforms both CIFS and NFS. And an iSCSI initiator connects to an iSCSI target server to attach to a storage LUN. So iSCSI connected storage appears to your machine exactly like a physical hard drive. And in my iSCSI tutorial, I talked about how we can connect a Windows machine as well as a Linux machine, and I showed how that storage space actually does show up just as though you had installed an additional hard drive to the hardware interface inside of a machine. So this is useful when you have no way to attach a drive to your system internally, but you need more storage. And that happens many times if you have chosen a mini PC to use as your Incus server, which is very efficient in terms of your power consumption and your heat generation, and even the outright cost of the unit. But unfortunately, as your requirements grow, you may find that you need additional storage. So what about using Incus with iSCSI? Well, we're going to configure an iSCSI initiator on our Incus server. And we're going to connect to an iSCSI target on a remote system to access additional storage. And then we're going to use the iSCSI attached storage to create an additional ZFS pool for our Incus server. And then I'm going to show how to create containers on the new storage pool, and also how to move an existing container to the new storage pool. So with that in mind, let's go see how to use iSCSI with an Incus server. Here we are in one of my Incus demo servers, and if we do an Incus storage list, we can see the default storage pool, which is of type ZFS, and that was created with the Incus admin init that we presented in the Incus step-by-step video. We can also do a sudo zpool list, and we have to go ahead and enter our sudo password, and you can see the storage utilization in that default ZFS file pool. I don't presently have any containers in here, and Incus list shows that. However, I can do an Incus storage volume list default, and we have some things in that default storage pool. Namely, in the previous video, when I created Plex, I had the Plex data volume, the Plex movies volume, and the Plex TV volume that I've left behind because I had not yet deleted them. And the other three images are probably things like container images used to create containers, like perhaps Ubuntu 2204 and Ubuntu 2404. So we have volumes taking up space inside of the storage pool. It's not really a problem that we have things taking up space in the storage pool, and in this particular case, I have a lot of free space. But we can create another storage pool that can be a virtual storage pool. That means a storage pool created inside of a file, just like we did with the Incus admin init, and we can do that by creating a file. So in this particular case, I'm in the home Scott folder, and so I'm doing a truncate, and I'm saying make the size 50 gigabytes, and it goes ahead and does that. If I do an ls-al down here, we can see that there is a 50 gigabyte file called pool2.img. To create a ZFS pool that uses this file, I can do a sudo zpool create pool2, which is the name of the pool that I'm going to create, and then point to that particular file, and then at the end a -m is none, which means that it has no mount point. And the reason I'm not giving it a mount point is because I intend to use that pool with Incus. So therefore, I can now do an Incus storage create pool2 of type ZFS, where the source is the ZFS pool named pool2. And now it has created that storage pool. And if we do a sudo zpool list, we'll see both storage pools, the original default storage pool and now pool 2. To use this virtual pool more easily, I'm going to do an Incus profile create pool 2, and that is a profile named pool 2, which was just an arbitrary name. And then I'm going to do an Incus profile edit pool 2. At this point, this profile really doesn't do anything, but I'm going to use a whole bunch of control Ks to simply clear out the contents of the file, and I'm going to go ahead and paste in my own file. And I'm basically giving it the description pool2 Incus profile, where the device is going to be ETH0, which is the standard name of the first Ethernet device inside of a container. I'm saying the network is Incus BR0 because that's what we get with the normal default profile. And then the type is NIC, but the important part here is that the path is to root, which is normal inside of the container, but the pool we're going to use is a pool named pool2. So now I do a Control O and Enter to write the file out, and a Control X to exit the nano editor. Now I can create a container in our new pool2 with the command incus launch images :ubuntu/2404, and I'm calling the name of this container container 1, and I'm putting the profile pool 2 in place, which points to pool 2. And then boot.autostart equals to true. So it's creating that container, but it's creating the container inside of pool 2. The container 1 container is now started in pool 2, and we can do a Incus storage list pool 2, and it says that pool 2 is being used by 3 objects. We can see the objects using pool 2 by doing an Incus storage volume list pool 2. And in this case, there's really only 2 objects, which are container 1, which is the actual container we created, and then the downloaded image here, which is the downloaded image for the Ubuntu 2404 that was used to create the container. So the third object is the pool 2 profile that we created. Since we have objects using space in pool 2, we can do a sudo zpool list, and pool 2 is currently using 257 megabytes for the container 1, the image for 2404, along with the profile that we just created. The purpose of the previous steps was just to become aware of how we manage a container in another storage pool. So with that in mind, let's go ahead and stop container 1, and let's go ahead and remove container 1. I could have used RM or delete there. Let's delete the profile for pool 2 with an Incus profile delete pool 2. Let's delete the storage pool from the Incus perspective with an Incus storage delete pool 2. If we now do a sudo zpool list, only the default pool is here. However, we still have the large file here, and if we do an ls-al, you'll notice that pool2.image still exists, and it's taking up the 50 gigabytes of space. So we can go ahead and delete that file with an rm on pool2.img, and now we've freed up that space. In my iSCSI Fast Network-based storage presentation, I pointed out that we use iSCSI as an initiator from where we want to mount the storage space, and then the iSCSI target is where the storage space is located. And we're not going to cover setting up the iSCSI target, since that was explained in iSCSI Fast Network-based storage, but we're going to be turning our Incus server here into an iSCSI initiator to mount storage elsewhere on the network. So to begin with, if we do an ls-blk, we can see all of the storage here on this local device, and we have a bunch of loop devices, and loop devices are required for things like snap, and that's just virtual mounting of something. And then we have our NVMe 0 and 1 device, and it happens to have 3 partitions on it. Since the iSCSI protocol is not configured by default, we want to go ahead and do a sudo apt install open-iSCSI. And it looks like on this particular server, for whatever reason, OpenISCSI was initially installed, and that may not be the case on your system. Now we want to do a discovery on our target server, so I do a sudo iSCSI ADM discovery, and the target node is the address of my QNAP NAS, which is my iSCSI target. And here it's found 3 iSCSI volumes, our iSCSI targets. One is called Mondo Store, one is called Mondo 2, and one is called Utility. So the first thing I want to do is go out here and copy this IQN, which I'm going to use in this next step. We want to edit the iSCSI initiator file, and that is over on /etsy/iSCSI initiator.iSCSI. And so that file may have a few lines in it already. If it does, feel free to delete them. And then I'm going to go ahead and put in initiator name equals, and that IQN I copied in the previous step. So now I do a Control O and Enter to save the file out, and a Control X to exit the Nano editor. Now I want to edit the iSCSI configuration file, which is in /etsy/iSCSI iSCSID.conf. And going into this file, we want to make sure as we scroll down that we have this line uncommented for iSCSI.startup, and then iSCSI startup here. I don't think you really need this line uncommented, but as we move further down in the list, we want to make sure that our node.startup equals automatic, and that should be all the changes you need to make here, unless you want to turn on authentication for your iSCSI services, in which case you would uncomment this authentication method equal to chap, which we're not going to do. And then if you move further down the list, they have a node.session.auth.username and a node.session.auth.password, and you would uncomment those if you had a username and a password associated with your iSCSI target. So now I'll go ahead and do a Control O and Enter to write the file out, and a Control X to exit the Nano editor. Since we made changes to the iSCSI configuration file, we're going to have to restart both the iSCSI daemon and open iSCSI with a systemctl, restart iSCSI-D, and open iSCSI. Next, we perform an iSCSI session command with iSCSI adm-m session-o show, and it indicates that on this particular iSCSI target, I have 3 targets, one called Mondo Store, one called Mondo 2, and one called Utility. Just as a reminder again, if we do an lsblk, we'll notice here that we have our SDA and our SDB and our SDC. So if we look at SDC, we can see that it is a 4.2 terabyte disk, and that is actually the utility disk. And I can also tell because it has no partitions that have yet been created on it. Since I don't really want to connect to all of the iSCSI targets on that node, and I only want to connect to the utility target, I'm going to go ahead and create a new record in the iSCSI configuration with the command sudo iSCSI adm, and the mode is node, and I indicate my target IQN, which is the iSCSI utility over there, and it's targeted at the address of that iSCSI target node. So it says that it's added that new node in there, and then I also have to use that discovery setting that I just created to create a send targets record, and I do that with this command here. And that will go ahead and list out everything. If we scroll up in this list to the very top, you'll notice that it says node startup equals automatic, and that's exactly what we want. We want an automatic record, which means that it will show up on reboot. Just to verify that this configuration is persistent, I'm going to go ahead and change over to the root account by doing a sudo su, and then I'm going to cd over into /etsy/iSCSI/nodes. Here, if I do an ls, we've got a whole bunch of entries down here in this folder, but the one that I'm interested in is the one that says that it is for the utility service at 363912. So I'm going to go ahead and copy that and CD into that folder. And then in there, I'll do another ls, and believe it or not, this thing is also a folder, and I'll go ahead and CD inside of it. And then when I do an ls, there is a default file. If I do a nano on that default file, we want to check and see that node.startup is automatic, but since we saw that in the previous listing, we're pretty sure that that's the case. So at this point in time, I'll simply do a reboot now, and I don't have to use the sudo since I'm already inside of the root account. So here's Scott from the future, and after the reboot, I did an lsblk, and I noticed that I had devices SDA, SDB, and SDC. But the only one I was interested in was the target named utility, and so therefore, here if I do a ls in this /etc /iSCSI /nodes folder, I went ahead and deleted the ones for the Mondo share, and I just kept the ones for the utility target. And once I did that and rebooted the system, I was able to do an lsblk, and I just have now the NVMe drive, which of course is local to the system, and the SDA, which is the 4.2 terabyte iSCSI target. At this point, we verified that we can connect to our iSCSI drive and that it will connect upon reboot. If I do an Incus storage list, we're only going to see the default storage pool at this point in time. And if I do a sudo zpool list, we're only going to see the default ZFS file pool. So now we can use our new storage with the command incus storage create, and I'm going to go ahead and name this pool pool2 from the perspective of Incus, and it will be type ZFS, and the source will be /dev/SDA, not SDC as I previously had, and then ZFS.pool_name equals iSCSI-pool. And by doing that, it will be named iSCSI-pool from the perspective of zpool list, but from the perspective of Incus storage list, it will be named pool2. So in order to use our new storage pool, we're going to begin by creating a profile called pool2, and I could have arbitrarily really named it anything that I wanted to, and then we're going to go and edit pool2 with an Incus profile edit pool2. I'll go ahead and use a series of Control Ks to clear out the contents of this particular file, and then I'm going to paste in the new contents, which of course will be in the show notes, and those contents are basically pool2 Incus profile, and then its device ETH0, and this is the same profile that we had created earlier when we had the virtual ZFS file pool that I had demonstrated. And again, we're looking at pool 2. So we'll do a Control O and enter to write that profile out, and a Control X to exit the nano editor. And at this point in time, we can go ahead and create a new container on that storage pool with an Incus launch images :ubuntu /2404. I'm calling the container, again, container 1, and this time we're pointing it to the pool2 profile, which of course will place the container in pool2, and then I have boot.autostart equal to true, which means that any time that the Incus server starts, this particular container starts. And now it has pulled that container and it has gone ahead and launched it. So if I do an Incus list, we can't really tell that it's running in pool 2, but we can do an Incus storage volume list pool 2. And there you'll see that we have container 1 running in pool 2, and this image was simply the Ubuntu 24.04 image that it had to pull down in order to create the container. I could delete that, but there's no real reason to do that. And likewise, if I turned around and did an Incus storage or an Incus zpool list, we now have 257 megabytes used out of our 4.19 terabytes. So if I had a container that had some really large storage needs, I could go ahead and point it into pool 2, which is an iSCSI pool being mounted on my QNAP NAS elsewhere in my network, but it performs and operates just as though it was locally installed hardware on the Demo 2 server. If we do an Incus storage list, and suppose we had a lot of containers running on the default storage pool and we were running out of space and we really wanted them to be on storage pool 2. If I do an Incus list right now, we only have one container. So let's go ahead and create ourselves a second container, and we'll create a container that's called container 2, but we won't specify a storage pool, which will cause container 2 to get created in storage pool 1. And to verify that, if we do an Incus storage list again, we'll see that the default pool now has 8 objects using it. And so if we do an Incus list, we now have both container 1 and container 2. In order to move a container from one pool to another, first we have to stop it, so we'll do an Incus stop on container 2, which is the new container that we just created in the default pool, and we'll go ahead and move him over to pool 2. And we do that with an Incus move container 2 over to new. I'm just arbitrarily and temporarily creating the name new because you can't do a move to the same name, and -s equals pool 2, which is the name of the pool that I want to move the container to. And now if I do an Incus list, the container 2 is now called new, but I don't want it to be called new, so I'm going to go ahead and rename it back to container 2 now that it's moved with an Incus move new to container 2. And now if I do an Incus list, we have container 1 and container 2. If I now go back and do the Incus storage list command, I can see that we've decremented the number of containers in the default storage pool and incremented the number of containers in the pool 2 pool. So in summary, sometimes an application in Incus has a larger storage requirement. And in previous videos, we learned how to use Incus volumes and also mount supplemental storage space for a particular container using NFS. So iSCSI is a block-oriented storage, which is much faster than NFS files-oriented storage. And we showed how to make an Incus server, an iSCSI initiator, and how to attach that to an iSCSI target to expand available disk storage. And we showed how to configure that additional space as a ZFS storage pool for your Incus server. Anyway, that's it for today. Please subscribe and like to the channel, and don't forget to hit your notification bell, and we'll see you next time.